All right, circles practice B, equations of circles. So before we get started, let me just kind of write down the generic equation. So it's always in the form x minus h squared plus y minus k squared equals r squared. And what you need to realize here is that the center of every circle is at hk, and the radius is r. So this number over here is always the square of the radius. And then whatever follows the minus sign is going to be your center. All right? And you got to be kind of careful though, because if you see x plus h squared, it's going to be the opposite. It's going to be a negative number in your parentheses. So just kind of something you want to keep track of there. All right? So with that being said, let's get into it. So number one, which of the following is the equation of a circle with a center of 0, 4 and a radius of, with an endpoint of 4/3, 5? All right, well, let's deal with this first part. If you have a center of 0, 4, that means you're at x minus 0 plus y minus 4. So even notice it looks like negative 4. It's really positive, just because that's the way the equation's set up. And then we have r squared. So first things first, this can be simplified to just x squared. Well, right away I can eliminate b and I can eliminate d because both of those had plus instead of the minus that we're supposed to have. So that kind of got me right down to a 50-50. Now let's actually get into what the heck this radius is. So I have a center at 0, 4 and then a radius ending at that point. So let's just kind of draw this circle here a little bit. So my center is at 0, 4 and the radius ends at 4/3, 5. Well, 4/3, there's 1, 2, 4/3 is going to be right at about 1 1/3. Then we're going to go up to 5. So we're at 1 1/3, 5. And that's our radius. Well, I'm going to need, because it's on a coordinate grid, I'm going to need to find the distance between those 2 points. So my point is at 0, 4, and then my other point is at 4/3, 5. So I can do a little Pythagorean theorem move here. So my height goes from 4 to 5, so this is going to be 1. And then over here on the side, from x of 0 to 1 1/3, so that's 4/3. So let's do a little Pythagorean theorem move. So we have leg squared plus leg squared equals the radius squared. Well, 1 times itself is 1. 4/3 times 4/3 is 16/9. And to get a common denominator, 1 is the same as 9/9. So 9/9 plus 16/9 is 25/9, which is r squared. Normally I'd take the square root of both sides, but we don't need to because the formula here wants r squared. So 25/9 is actually in the formula. Now, if they would have asked what is the radius, if they wanted to know the radius, I would have had to square root both sides, and the radius would have been 5/3. So they wanted you to pick that answer. That was a good distractor, but that would be somebody that forgets that in the formula it's actually r squared, not r. Number 2, a circle of the plane has a center of 5, 7, radius of 2, so this one's pretty straightforward. X minus the x coordinate, and then y minus the y coordinate. And then this is supposed to be r squared, so if the radius is 2, it's 2 squared, or 4. So, we can get rid of these two because they both have pluses instead of minuses. And correct answer is A. Number 3, pretty tricky here. And this is one that if you're not very familiar with how to do this, you may want to go back and watch some videos on how to complete the square of a quadratic. But that's what we're going to have to do, and the SAT seems to really love this move. Because if you notice, our equation is not in the correct form. You know, we're wanting to have parentheses and squared. So let me show you how we solve this. So we have x squared, and I'm going to gather the x term up with it. So I'm going to kind of put these two together. And then I'm going to leave a space to complete the square. And then I'm going to do the y terms, y squared minus 2y. And I'm going to leave a space equals negative 1. All right, and what I'm hoping to do is, I'm hoping to get this thing into a format that looks a little bit more like what we need for the equation of a circle. So here's how you complete the square. You basically take this b term, this middle term. Remember, a is in front of x squared, b is in front of the x, c, that's kind of standard form for a quadratic. You take that b term and you chop it in half. So positive 4 chopped in half is plus 2. And then you're going to square it. Positive 2 times itself is 4. So what I've done is I've created a perfect square that can be factored. Nice. And then I do the same thing over here. So I take this b term and I chop it in half. Half of negative 2 is negative 1. And then I multiply negative 1 times itself is positive 1. And you'll notice that all of a sudden now we've added 4 and 1 to the original equation for a total of 5. So we need to add 5 to the right-hand side to keep the equation balanced. Well, now on the right-hand side we have negative 1 plus 5 is 4. And I think we have a really nice looking equation of a circle. So we can see that the center is at negative 2, positive 1. Remember, they're opposites. And then this is r squared. So the radius is 2. So this is the center. That's the radius. Let's see what they want. They want to know what is the radius. Correct answer is A. All right, number 4, very similar to number 3. Going to complete the square again, get a little bit more practice. So we have x squared plus 20x, leave a space, y squared plus 16y, leave a space, negative 20. So we're going to make this thing pretty. We're going to put it in nice standard circle form. Hopefully it makes our life a little bit easier. So here we go. We chop the b term in half, which is 10. And then we square it, and we put that right here. And then we chop the b term here in half, and then we square it. And so it looks like we've added 164 to the left, so we need to add 164 to the right. And combining these two terms gives us 144, which remember is our r squared. So our radius is 12. And if we want our center, it's going to be the opposite of that and the opposite of that. And this equation, they want to know what is the center. So the correct answer is B. And if you're getting confused about the opposite thing, remember that the formula is written x minus h squared. So the only way to get this expression is if h is negative 10, because then you'll have x minus a negative 10 squared, which really turns into x plus 10 squared. So that's a little bit tricky sometimes for students. All right, number 5, just because I see it's not in the right form, we're probably going to have to do some completing the square. Looks like with an extra little twist on this one. So, you know, I have 2x squared minus 6x, leave a space, get my y terms together, leave a space, 45. Right away, I don't like these 2's as coefficients, so I'm going to divide everybody by 2. So dividing the whole thing by 2, I get x squared minus 3x, y squared plus 1y equals 22.5. So all I did was I divided everybody by 2 there. And now we're going to complete the square. We should be in pretty good shape to do this. I'm going to kind of do my standard move where I chop this number in half, and then I square it, and negative 1.5 times itself is 2.25. Chop this positive 1 in half, and then square it. 0.5 times 0.5 is 0.25. So you'll notice we added an additional 2.5 to the right. So to keep it balanced, we got to add it to the left, which gives us a total over here of 25. And ultimate goal is they want the radius of the circle. So remember, this right here is r squared. So if I take the square root of both sides, it looks like the radius is 5. Correct answer, A. Number 6, a circle in the plane has an equation. They give it to me. Which of the following points does not, so be careful right there, does not lie in the inside of the circle? So I think I better sketch a graph of this one. So sifting through the information, it looks like our center is at -3, +1, and my radius is 5. All right, and I got all that information similar to how I did on the problems before. And let's just kind of sketch this. Center is at -3, 1. So 1, 2, there's -3, 1. And then a radius of 5 means I'm going to go out 5 in every direction. So 1, 2, 3, 4, 5. So that takes me to 2. If I go up 5, 1, 2, 3, 4, 5, that takes me up to 6. Then if I go this way, 1, 2, 3, 4, 5. That takes me 5 more, will take me over to -8. And then down, 1, 2, 3, 4, 5, takes me all the way down to -4. So basically all I did was I started at the center and I kind of went 5, the radius, in all the directions. And then we'll have this circle. It's kind of a rough, nasty sketch. It's quick and dirty is all we need. Now we got to see which of the following does not lie in the inside. Well, let's test A. -7, 3. -7, 3 looks like it would... Whoa, where are you going on me? -7, 3 looks like it would live right up in here somewhere. So that one looks good. -3, 1, well, that lives inside. That's the center. 0, 0 looks good, so I'm getting kind of nervous. 3, 2, there we are. 3, 2, chilling out here, does not lie in the interior. So the correct answer is D. Number 7, we have the equation of a circle. Let's just sift out what we need from that. We know that the center is +6, -5. We also know that the radius is 4. And let's see. And it says point P is on the circle, has coordinates of 10, -5. PQ is the diameter. What's Q? Well, let's sketch this sucker. And our center is at +6, -5. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So there's our center. We know the radius is 4, so that's going to take me 7, 8, 9, 10 over in this direction. So that point is at 10, -5, which is the point P they were talking about. So we now have our point P. Well, if PQ is a diameter, that goes through the center. So, if this was 4 spaces over, Q needs to be 4 spaces backwards. So 1, 2, 3, 4 backwards would put me right here, which would be our Q, which is located at 2, -5. So the coordinate of Q is A, 2, -5. So there's our diameter. We didn't really need to draw it, but our circle would look something like that. Number 8, coordinate grid. We have a circle. We have a couple of crossing points. So it says the circle has a center of HK and a radius of 10. What is the value of K? So ultimately, K represents the Y value, or the height. So I'm trying to figure out how far up this thing goes. The only clue they really give me was that the radius was 10. So I'm going to draw a radius in here of 10. I'm going to draw a radius in here of 10. So I have an isosceles triangle. And I'm going to kind of drop, drop a little line down, which that right there should be right in the center. So if you're looking from x equals 4, all the way to x equals 20, that's a space of 16. And if I split that up, that's going to be 8 and 8. Well, this is a nice little Pythagorean triangle right here. You could use Pythagorean theorem, but I know a lot of times they really like to use this 3, 4, 5 triangle. And if you notice, this is just a double of this. So 4 is doubled to be 8, 5 is doubled to be 10. So this height right here is doubled to be 6. So right there, that height of 6 tells me how far up K is. K is at a height of 6. So the correct answer here is 6.